walk you through what we have done for the machine learning project. So the topic again is supporting human decision making for regulatory adherence with machine learning. And let me start by showing you this slide that I have borrowed from an earlier BigML presentation, which kind of shows two extremes on the approach to building machine learning applications. So on the left hand, you see kind of like a heavy academic approach where we build data science teams, focus on algorithms and theory, where it takes months and maybe years to build out a solution that actually works, not being scalable, and models that basically never make it to production. And on the other side, we have applied machine learning, where we have a very small team, machine learning engineer, an architect, front-end developer, where we really focus on the business problems, where we have iterations. So we have an iteration, we learn from it, and we enhance whatever we have built. Have something that is highly scalable and actually running on production. So hopefully not coming as a surprise, this is exactly the approach that we have taken to build out well, one of the first, hopefully of many machine learning applications integrated into the GRC tool. So let me just walk you through on a very high level kind of the stages that we have gone through. So machine learning was quite new to the team, where the stakeholders are basically part of the GRC tool team of Rabobank, and the business who will actually be using the solution in the end. And together with the business, we try to identify use cases. So I will talk a bit more about the whole process of the actual use case that we have built out. But together with the business, we have looked at the workflow of their daily operations, their daily work, and try to identify stuff where we can use machine learning to automate stuff that is not so easy to automate using, let's say, traditional methods. So those use cases we then sorted based on, priority, complexity, business value, and we selected an initial use case and built out a proof of concept. So what we try to do is let machine learning land to build something tangible, to let it prove itself, and so that it, the door opens for additional use cases if this would be a success. So after building out that proof of concept, we deployed it into production, where we added some stuff on top of it. So obviously we optimized it a little bit further. We integrated and automated it. So integrated the machine learning tool with the GRC platform, automate the predictions, actually perform the predictions and measure the impact. So some, quick small keywords is we started small, iterative approach. We wanted to show quick results and build trust. Augmented intelligence, so instead of just automating everything that we can automate, this is meant to support human decision making, where hopefully we can increase the workforce productivity. We have a focus on qualitative and quantitative values, so stuff that you can measure, but also taking into account value for end users for stuff that they now have to do, which is potentially not maybe not the most fun part of the job. And if we can automate parts and actually help users, it will make them more happy. So that's more of the qualitative value. And clearly defined success criteria. So when do we all, including and especially actually the business, think this is a success? So in the end, we ended up using or setting up a use case where we are trying to work with content externally provided, automatically imported into the GRC tool, which basically provides information on changes in regulation, important news on regulatory adherence. And there's an ever increasing amount of this content that is being brought into the tool. And what then needs to happen is by looking at the content, we need to decide whether this intel is relevant, first of all, and second, what the impact is to the organization. And it can be many different things, from so many different document types. This is an example of a regulation brought in by various issuing authorities. So on average, over the past like two-ish years, 450 new items a month have been received. And then for each item, the applicability, relevance, and impact to the organization needs to be determined. Now, there are three clauses, basically: regulatory, informational, and not relevant. So for each of those 450 items, it can fall into one of these three clauses, where regulatory means it's very applicable to the organization and it actually requires follow-up. We need to perform an actual impact assessment. For informational, it's applicable, but we don't need any follow-up. And then we have a third clause, which basically it's not applicable to the organization, so we don't need to do anything. And as you can see, the percentage of total is 35 for the not relevant. So out of those 450 new items, quite a lot is actually not relevant. So this actually shows the full process, and I will walk you through on a high level. Basically what happens is we receive the regulatory content, it's imported into the GRC tooling, then using manually managed mapping tables. So this again is an example of an imported record. And then based on business rules, manually created, determined, and managed, the intelligence type is then determined. So as you can see, so if the issuing authority is Council of Europe, or the DNB, the Dutch bank, and the document type equals report, bulletin, then the intelligence type is informational. And that is kind of an important field over here, or feature, because then a regulatory expert is going to look at those items and going to determine, is this actually correctly classified by those manually managed rules, and if so, then we need to perform a quick scan, and a quick scan is just a series of like some questions that you need to answer to determine the overall relevance. When the overall relevance is medium or high, then we need to actually perform a full-blown assessment. So what have we decided to do and try and automate is actually this part, where we have those manually managed mapping tables, and can't we replace them with a machine learning model to give us the predictions? So it all starts with formulating a research question that contains everything. So it's a long sentence. Can we determine the intelligence type based on the raw content provider data with a recall of at least 75% in precision, of at least 70 for the regulatory clause? It's a mouthful, but I've already kind of parsed it, and let's start with the important thing is what are we going to do? We're going to try and determine the intelligence type based on classification, based on raw content provider data. So this is the actual data that we are going to work with, and this is automatically imported into the tool. And then with a recall and precision of certain percent for the regulatory clause, this all is related to the evaluation that we do. When what needs to be the performance of the model for us to be happy. So walking through the machine learning process is basically state a problem as an ML task, do data wrangling and feature engineering. So really looking at the data, do whatever we need to do, filtering, cleaning up, creating new features, then learn from the data. So then we create the models, we test them and evaluate, and we deploy to production, we predict, and we measure the impact. So the first thing that we actually did is creating a proof of concept, which was quite a quick process. Within 1.5 months, we already had a good proof of concept running. So to focus a bit more on, to make it tangible, visible, is the first part is looking at those records in the GRC tool containing the regulatory data, then importing it into BigML, and do the whole data wrangling feature engineering, where we then learn from the data, we generate the models, and we have tested and tried out many different models, obviously, and all with different evaluation or different performance. And with the best model or the best models, we ended up making the predictions, where we have also basically integrated the results from BigML into the GRC tool. So basically, we're asking BigML from our GRC tool, we're asking BigML, give us the predictions, give us the confidence scores, import it back into the GRC tool so that it's all in the same environment. And basically, you could see the GRC tool as the front end tool. So we didn't necessarily need to build a separate tool. We actually used an existing tool, which is basically the GRC tool. And then over time, obviously, the performance will degrade, and we need to retrain the model. So on top of that, we also built an anomaly detection. And this is basically to identify whether the new data that needs to be predicted is still recognizable for the model. So does the model recognize the data that we presented? If so, then all good. And then the anomaly score will be low. However, if it's completely new data to the model and then the model doesn't necessarily know what to do with the data, then the anomaly score will be high. And as you can see, and this is an actual record from the GRC tool, and it's that record that contains the regulatory intel. We can see here over here what's the intelligence, the predicted intelligence type. We see the confidence score. So this is a kind of a high confidence score for this prediction. And we see on the right-hand side the anomaly score, which is low. And that then has been summed up into a field called trust level, and which can be red, amber, or green, indicating to the user, and by only like one short look at it, what is the predicted intelligence type, and can I trust this intelligence type? At least how sure is the model, and how well does the model know the data that we have presented? This shows a bit of the flow behind the hood on what we have, how we have done this. So from the source, creating a data set, doing filtering on it, no missing values. We have looked at data quality and identified that data from earlier than 2020 was not so good quality. So we have only been looking at data from after 2020. And from there, we have created a topic model, and then built on top of that an anomaly detector. And on the other hand, we have created a bunch of models and fused them into one to actually get our good performing model. And this whole process is actually automated in BigML. So you can script it, you can import new data, press on the button, and BigML will create all of this for you. This slide is about creating the model and basically training the model and retraining the model. And this slide is about, okay, so now we have new data. The content provider provides it, it's imported into the GRC tool. Then the GRC tool will request or will send the data to BigML, which will then run it through the model and the anomaly detector, send the predictions back, where after which it is imported into the GRC tool. And the nice thing is that because we have all of the predictions, all of the confidence scores, all of the anomaly scores actually in Archer or in the GRC tool, we can actually show it. We can show it in reports, on dashboards, and this will provide end users with insights into how the model is performing over time, and going forward. Can we still? Is the model still performing well enough? And you can drill through and look at the details for each regulatory intel item. This is the same kind of report, but then showing the trust level. And then behind the scenes as well, we have the confidence score, the distribution group by month over the confidence score, and the anomaly scores. So the results. It gave us a number of positive outcomes expected and hoped for, as well as not necessarily expected. So there was a significant decrease in time required to keep the rules up to date. So this is about retraining the model with the existing data versus analyzing and maintaining the manual business rules, which will even become more complex over time, because there's just it's very likely that there will be more kinds of documents or different kinds of document types, or potentially additional issuing of authorities that you haven't captured at the moment in the manual business rules. But for the model, this is it's all about retraining the model to have it included. So automating of work that's tedious and complex when done manually, which is basically analyzing and writing the growing number of business rules. And this is a very important one and a very good outcome. It's basically the realization that the data quality should be improved. So, the performance of the model depends on what you put in. The famous garbage in is garbage out. And it can only distill all of the rules for you and create the model based on the data that you provided with. And the more and better you have defined your way of working, and for example, agree on the fact that all of the experts think it's the same, it belongs, a regulatory intel belongs to the same class, rather than that one expert thinks it's informational and the other thinks it's regulatory, and yet another thinks it's not relevant. So this actually resulted in a project as well to improve the process and formal definitions. And yeah, very interesting. Obviously, it increased awareness and the interest it sparked in machine learning, triggering a lot of ideas for future use cases or for other use cases. So next steps, stakeholders are very enthusiastic, and a number of actions have been defined, increasing the knowledge of machine learning within the teams. So have a better understanding of what it can do and also what it can't do. Determine what should be done to optimally incorporate the machine learning outcomes into the existing business process. So the predictions are there, but how should end users interpret it? Basically, do we initially want to show both the results from the calculated and manually set up business rules and the results of the machine learning outcomes to have a comparison side by side, or are we gonna jump directly into the machine learning predictions? In the end, we started with basically a soft landing and having both of the information on the record. So further improve the data quality, obviously, to further improve the quality of the model and predictions. Identify and implement new use cases and find opportunities to apply machine learning in other domains. So the next steps for potential use cases are so the improvement of the intelligence type use case. So a number of things that can be done, improving the quality of the historical data, but also including the full text rather than only the title and the abstract of the text. And fully automate the model retraining process. So right now, the process of retraining itself has been automated, but the trigger to actually retrain has not been automated. And this is a step that you could do to make it like a continuous and seamless experience. So the intelligence item assignment, so after it has come in, it's then handed over to let's say the applicable team, and it depends on the content to what team it should go to. And this is a process that is also covered with manual business rules, and where we have high expectations that machine learning can do a very good job at it. Quick scan automation, so for each intel item, a quick scan needs to be performed. And using machine learning, this could be automated. And then as a next step, the impact assessment automation. So that's actually the full-blown intel item where it needs to be determined what the relevance is, but also what relevant other objects are impacted. So think of business processes, policies, risks, controls. So these are potential use cases for the future.